thing. We're going to go off and talk about compound angles today. We're just doing the basics to start off with, and then we will certainly start to do some of the sort of slightly more difficult questions. All right, so the first thing that I wanted to discuss with you is what a compound angle is. All right, so if I didn't know what a compound angle was and it was your job to explain it to me, what would you tell me? How would you explain to me what a compound angle is? Is anybody confident enough to be able to explain that?
Ma'am.
Yes, Ria, go for it.
I don't know. I might be very wrong right now, but I'm just guessing that a compound angle involves the trigonometric ratio of the sum of two angles or the difference between two angles.
Okay, absolutely. Okay, so it's either two angles added together or one angle minus another angle. So how those angles are created, good, well done. How those angles are created on the Cartesian plane would be as follows. So let's say I decided to go 60 degrees in this direction, and then I decided to go another alpha degrees in the same direction. This entire angle over here could be written as 60 plus alpha or alpha plus 60, it doesn't matter. That's a compound angle. That's what they mean by the sum of two angles. If I went, again, so my terminal arm's anchored at the origin. Sorry, I forgot to say that in the first time. Let's say I went in this direction, all right, and I went 70 degrees in an anti-clockwise direction, and now I decided to come back this way a little bit. So let's say I came back here, and now I'm over there, and I came back theta degrees. All right, the difference between these two, so 70 the one way and theta the other way, means that the resulting angle is now going to be 70 minus theta degrees in size. That is how big it is. That's what compound angles are. Okay, so they're made by the sum of two angles or the difference of two angles. Right, so once we understand that, I think then going in and learning about our compound angle formulae kind of makes it a little bit easier to understand. What we need to remember, very important, is that we are not doing like what we did in grade 8, where we're learning to expand our brackets. So cos A minus B does not equal cos A minus cos B. All right, unfortunately not, it's not, that's not what it means. And a lot of us, when we do trig investigations, this is one of the things that we actually have to discover. All right, so there are 4 compound angles that you are expected to work with: cos A minus B, cos A plus B, sine A minus B, and sine A plus B. These will always be given to you. They're on your formula sheet. And please, 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 if you're referring to your formula sheet, make sure that you have copied them down correctly. It's so sad for us when we're marking matric work and you've been given the formulae and then they just don't get copied down correctly. All right, so at the very beginning of this section, we need to become competent in how we would expand these, right? So when we are doing the expansion, what we are talking about is going from the left-hand side to the right-hand side. So in other words, if I expand cos A plus B, I'm going to end up with what I've got on the right-hand side. So cos A cos B minus sine A sine B. When I go back the other way, I refer to that as the reversal of the expansion. So in other words, when I'm going in this direction over here, I am expanding. And when I go in that direction like that, I'm doing the reversal of the expansion. Okay, so from the left-hand side to the right-hand side, I'm expanding, and from the right back to the left, I'm doing the reversal of the expansion. So essentially what you are doing is you are writing your cos A cos B minus sine A sine B in terms of a single trig ratio. Okay, so in terms of cos, or if you had sine A cos B plus cos A sine B, you'd be writing that in terms of a single trig ratio. In this case, it would be sine A plus B. The other thing that we have to be aware of is our special angles. So if we've got special angles, we've got to use those values as well. So whether you use the fan or the triangles, or if your teacher's taught you a table, it doesn't matter. Any of those methods are perfectly acceptable. Okay, so I'm just going to do the first one and then I'm going to let you guys try the next two. This is supposed to be very, very easy. So let's try and see if we can get through it as fast as possible. I look at this and I see they want me to expand and they want me to expand x minus y. So I go and I find something that looks like this on my compound angle formula sheet, and I can see that it looks like this one over here. So expanding it, I would write cos x, cos y. Cos doesn't keep its sign, so that would be minus. And then here I would have sine x, sine y, like that. Okay, and that's as simple as it is when it comes to expanding. What I always teach my matrics to help them remember the difference between the cos and the sine is this: sine keeps its sign. Okay, so sine keeps its sign. So in other words, if you had a minus over here, you've got a minus over there. If you had a plus over here, you had a plus over there. Please note that with the cosine compound angles, it's the other way around. Okay, so just be careful of that when you are working with these. Nope, Amanda, because sorry, hang on a second. Now I'm saying what I'm saying to you, and then what I'm doing is not the same thing. Hang on. Cos, yes, that is supposed to be a plus. Sorry, it's exactly what I'm saying to you, and then I go and I do exactly that. Sorry, guys. Yes, absolutely. It's supposed to be cos x, cos y, plus sine x, sine y. My apologies. Yes. Okay, so what we were looking at was this one over here. So yes, it was supposed to have a plus. Thank you so much. All right, so now let's try the second one. Okay, is there anybody that feels confident enough to unmute and tell me what it is you think I should write here? Okay, so Clorky, okay, you've already provided an answer. All right, so you have said sine A cos 20 minus sine 20 cos A. All right, that's fine, not a problem. Okay, Lorato said the same thing, but those two were just switched around, which is the usual way that we would write it. No problem at all. Okay, so it doesn't matter if you write these in a different order. It does mean the same thing. It's just important when you're doing the reversal of the expansion to have them in the correct order. Okay, let's have a look at number 3. Anybody feeling confident to tell me what we should write in number 3? Does anybody want to unmute and speak? What should we write in number 3?
Let's go, Matrix. We can do this. Do you want me to pick on someone? Because I can. I can just pick on someone. Chloe, are you there? Do you want to give us number 3 as an answer? Okay. Zanake came to the rescue.
There we go. Go for it. What should we write?
Ma'am.
Hi.
Ma'am, ma'am, for number 3, it is sine 2a cos 2a minus sine 45 cos 2a.
Okay. All right. Now there's something that's not correct here. Okay, because I'm using sine 2a plus 45. So that looks like this one over here, sine a plus 45. So that should be sine 2a. Then over here, it should be cos of angle B. So this here should be 45 degrees. Okay, so let's just change that, whoopsie, to 45 degrees. Okay, and then again here, I'm just going to put these in the correct order. This was right. Let's just get the, not that it actually matters, but anyway, so this over here would be cos 2a, and then it would be sine 45 degrees. Absolutely. All right, cool. There we go. So now that we have done that, now that we've done the expansion, we can see we've got special angles. So how would we write cos of 45 degrees, Matrix? Okay, Tsagofatso, go for it.
Ma'am, it's actually a question.
Mm-hmm. What's your
Why
question?
is it a minus? Because it's supposed to be a plus.
Sorry, my brain is obviously turned to mush this evening. You are quite right. Sine keeps it sine. Okay, quite right.
Okay,
Well
ma'am.
done. Can you? No problem. You are quite right. Thank you. You know what I say at school when I make mistakes on the board? I say to the boys, I did that on purpose to see who was paying attention. So I'm going to say the same thing now. No, you're absolutely quite right. My apologies. It was supposed to be a plus, as I was emphasizing at the beginning of the lesson. All right, quite right. Okay, so we would write cos 45 as root 2 over 2 sine 2a plus, and then the sine of 45 is the same, so that would also be root 2 over 2 cos 2a. And that's all we would be able to do with it. Okay. Yes, like I don't know what's wrong with me today. Seriously. Sorry, that should be cos. Sorry, guys, I think it's end of term exhaustion. Okay, so root 2 over 2 sine 2a plus root 2 over 2 cos 2a. Okay, and then we have expanded it correctly. Okay, everybody happy with that? Are we all feeling okay? Okay, all right. My apologies for being so silly at the beginning of this lesson. All right, so let's just practice this a little bit and then we can dive into some slightly more complex questions. All right, so let's just make this a little bit bigger. Okay, and drag that down there so that we've got that to refer to. Okay, so the questions I'm going to get you guys to do, please, 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 you are going to do E, and you were going to do F, and you were going to do H if you were a fast finisher. Okay, so expand those and use compound angles where necessary, please, Matrix.
Let's go, Matrix. We are doing very well. Let's do this.
Except for me, I'm not doing very well. They're doing well, but not me.
We do all corrections, Teacher Lee. It's okay. We have our days.
Oh my goodness. Sure, Kagiso, you can say what you thought E was. Go for it, Kagiso. Tell us what you think we should write.
Ma'am, yeah, okay. It's gonna end up as half cos A
Okay,
plus 1/, square root of 3/2 sine A.
100%. The problem is, Kagiso, is that you've got to show the step in between. Okay, so when you expand one of these formulae, you always get a mark for it. So expand it first, and then tell me your answer again. So go for it.
So cos 60 degrees
Yeah,
times cos A plus sine 60 degrees times sine A.
lovely.
Then
Okay, beautiful. And then
it'll
you
go to
said,
there. Then it's going to be half cos A plus square root of 3/2 sine A.
beautiful. You are a champ. Well done. Thank you so much. Excellent, excellent, excellent. Let's see if we've got someone who wants to try F. Okay, Ria, go for it, Ria Betswe. What did you write for F?
So F was kind of complicated, but the final, all these, okay, the step is like I wrote sine 45 times cos negative x minus cos 45 degrees times sine negative x.
Okay, it's not sine negative x. The angle is x. Okay, so it's this angle over here. I know it sounds so funny to say this because for years we've been telling you every term owns the sign in front of it, but your angle is a positive angle. Okay, so the angle is x. All right, so here this would be sine x like so.
So do I ignore the negative now?
Yes, so essentially when you were doing the expansion, yes, your angle is going to be positive here.
Always.
Okay. Always.
Okay, thank you, ma'am.
All right, no problem. Okay, so what we would need to do here, just move those out the way, is that we would then need to use special angles. All right, so the sine of 45, that would give us root 2/2 cos x, and then here the cos of 45, that would be root 2/2 sine x like so. Okay, so hopefully all of us had that answer as well. And then the last one, that's it, Lorato. Good, well done. Okay, the last one. Does anybody want to tell us what they had for the last one? Let's see who had their hand up first. Okay, iPhone. I'm sorry, I don't know who that is. Go for it. What did you have for cos A plus A?
You should tell us your name also.
Ma'am, I don't know. Hi, ma'am.
Hi.
I'm not sure if it keeps changing because you did change it the last time and then it went
Yeah,
back
and then
to
for some reason
iPhone.
it just keeps going back. I remember you did tell us your name last time. For some reason it doesn't seem to save the name. I don't know why.
No, we have to like
Yes, ma'am.
redo it every single time.
Yeah.
What's
Okay.
your name though?
It's-
Sorry, we will try and remember.
It's Ovayo Landa, ma'am. Ovayo.
Ovayo. Okay. Ovayo, go for it. What did
Yes,
you write?
Ma'am, I got cos squared A minus sine squared A.
Absolutely. Okay, so initially you would have written cos A, and then you would have written minus sine A, sine A. Good. All right, and you would have ended up with cos squared A minus sine squared A. Okay, lovely. Well done. Okay, and we actually, if we've started trig, we would actually know that that's one of our trig double angles as well. Okay, but we'll speak about that in time to come. Okay, so before we go on, are there any questions that you guys want to ask? Could we say Fazila? Yes, I suppose we could. I mean, in fact, up here, when we started off, we could say that cos A plus A is equal to cos 2A. All right, so that's why we do compound angles first and double angles second, because double angles actually come from compound angles. Okay, that's where they are derived from. Okay. Any other questions before we move on? Ria, I see your hand is up. Avio, I think this is because of earlier.
Oh, sorry, ma'am. Yeah, it was because of earlier.
Oh,
Sorry.
okay. All right. No, cool. No problem at all. All right. So let's jump in. How are you guys feeling so far? Do you want to do something a little bit more difficult? Are we ready to try something a little bit more challenging? Yes. Okay, cool. All right. So now let's have a look. Okay, I'm going to do one easy example, and then I'm going to do one that's a little bit more difficult. Okay, so if they gave us the expansion and they asked us to go back the other way to express it as a single trig ratio, then we need to make sure that what's on the right-hand side of our compound angle looks identical to what's in front of us before we could write it as a single trig ratio. So in the case of number 1 and number 2, these are really easy, but I'm going to do example G with you, and you're going to see how that one's just a little bit more difficult. So let's start with example number 2. All right, so we've got cos 70 cos x plus sine 70 sine x. So if we go and we have a look over here, we've got cos, sine, sine. So we know it's one of our cosine compound angle formulae. And obviously, because we've got a plus there, it would end up being a minus over here. So we could simply just write this as cos 70 minus x like so. Everybody happy with that? So that's how we would write it as a single trig ratio. Now let's consider this question over here, right? And what I'm going to do is I'm just going to scooch over a little bit to the side, and I want you guys to have a quick look at this, and I want you to tell me what's wrong with it. And when I say what's wrong with it, it's not as though there's a mistake, but I need to do something to this first. I need to do a little bit of manipulation. Okay, Ria, what do you think? What's wrong with question G? I say wrong in inverted commas.
Ma'am, you see now question G, right? The expansion for is going to be sine bracket A plus B, right? That one where it's sine A cos B plus cos A sine B. Like if you notice like the 40, not the 40, but the 4 theta and the 5 theta on the first like side is
In
not
the first term.
corresponding properly in the first term. It's not like corresponding properly with the second term, because like then it's going to be 5 theta and 4 theta. So you're going to have to manipulate it to kind of like correspond with the expansion, like where we get in the compound angle formula.
Absolutely. So we can't have sine first, then cos second, because then it doesn't look like our compound angle formula. All right. So the cos needs to be first, exactly Z2. So let me turn it around and let me put the cos first. Now I can't ignore the negative because this term over here is negative. So now I'm going to write this as negative cos 5 theta cos 4 theta plus sine 4 theta sine 5 theta. Okay, now what do I need to do to it? Because now I've got a negative in the front here. I don't have any negatives in the front in my formulae, but now I've got a negative in the front here. What am I going to do with that negative? Can anybody tell me? Factor it out. Quite right, Lorato. I'm going to factorize it out. So I'm going to take it out, close my brackets, and I'm going to write cos 5 theta cos 4 theta, and I mustn't forget to change my sign over here because the negative times a negative is a positive. All right, and then I'm just going to put my sine 5 theta first and my sine 4 theta second, so that it's in the same order as those over there. And now what can I do? It now looks like which one? Okay, it looks like this one over here. Okay, where I've got cos A cos B minus sine A sine B. So now I can do the reversal of the expansion, and I can write this as negative cos 5 theta plus 4 theta, which gives me negative cos 9 theta as my final answer. Okay. It's all right, Khomotsot. Glad you made it. All right, how are we feeling about that one, Matrix? Are we feeling good? Thumbs up, thumbs down. How do you feel? Good.
Nice, Matrix. Take
Nice, good.
screenshots, please.
Yep, absolutely. Good show, everybody. Oh, that's wonderful to see. Nice. Okay. Okay, so let's see. What I'm gonna do is I'm gonna jump forward and we are going to try one of these sorts of questions. So I want to get into these sort of slightly more difficult questions with you if possible. All right, so now they want us to apply the same thinking where we're going from the expansion to the reversal of the expansion, but we also have to use our grade 11 reduction formulae. Okay, so you can see here we're not allowed to use a calculator. Let's have a look at question number 2. Okay, so they've given us cos 10 sine 160 minus sine 10 sine 110. Okay, so now this one is a bit weird because we've got cosine and then we've got sine. Okay, so now that does not look anything like our compound angle formulae at all. Let me just go and grab them and drag them down here so that they're there visible on the page for you guys every time. So it doesn't look anything like that. Okay. We're not going to worry about that just yet. The first thing that we want to do is use reduction formulae. Okay, so any angle that's bigger than 90 needs to be reduced. So cos 10 is cool because it's 10 degrees. How am I going to write sine 160 once I have reduced it? We probably are going to use cofunctions, Amalia. Yes. Okay, how am I going to write sine 160 after I've reduced it? I'm going to write it as sine 20. Good, well done. Okay, minus sine 10 is not a problem. Okay, how am I going to write sine 110? How am I going to write sine 110 after I have done?
Ma'am,
Yes, Kagiso.
could it be that thing of 90 plus, ma'am?
It could be. It could be. We're gonna do that second. All right.
Okay.
We're going to do that second. Absolutely. In fact, I think Tando's done that first as well. All right. But most people are going with sine 70. Okay. Not a problem. So if we go with sine 70, we could do that. Okay, so 180 minus 70 gives us 110. But we've still got a problem here, guys, because our angle B's are not the same. We've got cos 10 sine 20, sine 10, sine 70. All right, so cos sine, sine. What are we going to manipulate now so that we've got cos sine, sine cos, or sine cos, cos sine rather? What can we do? It isn't Mehlali. Sine 140.
Sine
Okay.
140.
Sine 140
Okay.
is part of the
Sine
previous
140 is part of
question.
the previous question.
Sorry, I've muted everyone. One delay, please keep muted because it looks like it's feeding out the noise.
Yeah.
I'm not sure what's going on there.
We're doing question 2. We're not doing question 1. Okay, so you're looking at the wrong thing. Okay, one delay, you got your hand up. Do you want to tell me what to do or make a suggestion?
Ma'am,
Yes.
why can't you use sine 90 plus 20?
You can.
Yes, sine
That's
90
an alternative.
plus 20 which is cos
Absolutely.
110.
Absolutely.
Yes.
Okay, so if you said here sine 90 plus
90 plus 20.
Absolutely. So that's an alternative way of writing sine 110. So then how would you have written this term over here? You would have written it
Since
as?
it's as sine 20.
No. No, sine 90 plus 20 is not sine 20. Sine 90 plus 20 is? Shisana? Good. Okay, it would give us cos 20. Okay, so yes, you can do that straight away if you want to. All right, so if you want to do 180 minus 70 and write it as sine 70, that's fine. Or if you want to do sine 90 plus 20, you can write it as cos 20 straight away. All right, now the cos of 20 and the sine of 70 are the same. Okay, because they are co-ratios. So the cos of 90, sorry, the cos of 20 and the sine of 70, because 20 and 70 add up to 90, they are the same. All right, so absolutely we can do this. So what I'm going to do is I'm going to write the sine 20 first, cos 10 afterwards. Then I'm going to write minus, and I'm going to write that as cos 20, and then I'm going to put the sine 10 over there. Okay, so sine 70 has been written as cos 20. Now that I have got sine, cos, sine, I can use my compound angle formulae, and I can now do the reversal of the expansion. So sine keeps its sign. So this would leave me with 20 minus 10, and my final answer would be the sine of 10 degrees. Okay, Ria, did you want to ask a question?
Yes, ma'am. Ma'am, I
Go
wanted
for
to
it.
ask that. I wanted to ask, like, how do you know, like, how? Because, like, you see, number 2, right? It was cos 10 sine 20, but then, like, you changed them around to sine 20 cos 10. How did you know to do that?
Okay, so if you look at your formula, okay, if you look at your compound angle formula, all right, the sine, if it's a sine compound angle, we're writing sine A first. Okay, because I don't want 10 minus 20 and to end up with a negative angle. I must write sine first and cos second in my first term.
Okay, ma'am. Okay, I see it now.
Okay, all right, no problem. Now, Sihawu, you said, can you write sine 70 as 90 minus 20? Okay, so sine 70, okay. Yes, what you can do, Sihawu, is you can write that as the sine of 90 minus 20, and the sine of any angle of sine of 90 minus is the cos of that angle. Absolutely. So you can do that. Okay. It will end up being the same thing. Okay. All right. How are we feeling now? We feeling good? Okay, Mihlali, that is grade 11 reduction formulae. So 180 minus 20 is 160. Okay, it's a grade 11 reduction formula. All right, lovely. Okay, so now not only do we have to reduce, we also have to be able to use co-functions, then get our terms into the correct order, sine A cos B minus cos A sine B, whatever the case might be, and then we can do the reversal of the expansion. Okay, so let's try something a little bit more challenging. All right, so we've got these questions over here. All right. I don't want you to do question A because that is way too easy. So I want you guys to try and challenge yourselves if you're feeling confident about this, and a lot of you seem to know what you're doing. I want you to try C, or if you really, really want to challenge, then I want you to try question E. Okay, so give yourselves a few minutes and let's do those. Okay, Lorata, why you start with sine, not cos? Because we were working with the sine compound angle, not the cosine compound angle. Okay, so remember, we've always got to go back and refer to this. Okay, so if you have a look here, everybody else carry on going. When we are working with sine compound angles, sine A always comes first. When we are working with cosine compound angles, cos A always comes first. Okay. So there are your compound angles to help you. Okay, so either C or E, please, matrix.
Let's go, everybody. Let's do this. And this count a lot, teacher Lee, in their exams also.
Trig, yes, trig is a massive part. You can never ever do enough trig. Trig is a massive part of paper 2. So yes.
Nice.
Okay, and remember, no calculators allowed, matrix. Ria, you've got a question?
Ma'am, I wanted to ask for E, right?
Mm-hmm.
Do we simplify it to its final form? Like, for example, if the answer is cos 90, then it's equal to 0.
Correct. So you've got to keep going until it's, because I think the question here said that they wanted you to calculate the value of. Oh, it didn't say that. Yeah, supposed to be calculate the value of.
Let's go. We got this. We definitely have this. Think some answers already coming in.
Nice.
Yeah, keep those answers coming, guys.
Okay, so Pinga, cos 30. Okay, well, cos 30 is the same as the sine of 60. So I'd be interested to see how you ended up with that as an answer. Okay, if you've got cos 30 as an answer, you have to use special angles, okay?
Yep, to find the correct answer. 'Cause I think they do give marks for that, eh? When you find
They
the final
do.
answer. Because if you leave it
They
at cos 30,
do.
then they don't
Yeah, they
give you the
don't.
full mark.
That's right. Okay, so answers coming from Sashana, from Lorato, from Kamogelo. Okay, keep them coming in.
Sorry, ma'am. Could I please attempt C because I got a different answer?
All right, go for it.
So I said sine 280 and change that to sine 180 plus 100 cos
No,
180
you can't.
minus.
Wait, you can't do that. You can't do 180 plus 100 because 100 is not an acute angle. Okay, so sine 280 is in quadrant number 3. Okay,
Oh, thank
so
you.
you got to do, okay, that's where your mistake is. You got to do 180 plus. Okay,
Okay, thank
all
you.
right, no problem. All right, so a lot of you seem to be providing the correct answer for question C. All right,
Yeah.
Zetu, what's your question, Zetu?
Ma'am, for C, could you
Mm-hmm.
write 360? Could you write 360 minus 80 to get the 280? Because like I got sine 60 at the end, which is square root 3/2.
Yes, sorry, I don't know if I said the wrong thing earlier. Yes, so sorry, sine 280 is in the 4th quadrant. So yes, you'd have to use 360 minus.
Oh, okay, thank you, ma'am.
Yes, quite right. Okay, Kamogelo says E is equal to 1. We're going to work through these answers now. Okay, I'm going to start with C so long. So let's just get it down on paper.
So E, it's cos 65. It's cos 295. I can't even see this. Minus sine 115 cos 2. So then I got cos 90 minus 25 cos 360 minus.
Okay, so when it comes to sine 280, that's the 3rd quadrant. So sine would be negative, so that would be negative sine 80. Then cos 160, so that would be 2nd quadrant. So cos would be negative as well. So that would be negative cos 20. All right, then cos 100, that would also end up being negative because it's 2nd quadrant. So that would be negative cos 80. And sine 200 would be the 3rd quadrant, also negative, so that would be negative sine 20. Okay, so we have to write what we get when we reduce. Okay, so the second line is imperative. All right, now we have to say in the first term, a negative times a negative is a positive. So this gives us positive sine 80 cos 20. Then we've got a negative times another negative. So that'll give us a negative. And here it would be cos 80 sine 20. Okay, and now we've got sine cos, cos sine. Our angle A's are the same, our angle B's are the same. So now we're ready to use our compound angle formula to do the reversal of the expansion. This is a sine compound angle, and sine keeps its sign. So we would have said 80 minus 20, which gives us sine 60. And therefore, we would have ended up with the root 3/2, which so many of you said was the answer. Okay, so that was really good. Well done. Okay, so if you got root 3/2, that was perfect. Anybody try? Any questions on that? Any questions on that? Are we all feeling all right? Anybody try question E? Ria, did you try question E?
Yeah, I thought we
Yes,
had also
ma'am.
tried question.
Yes, ma'am, I did.
Okay, and Kamogelo tried as well. Okay, so Ria, do you want to try question E? Do you want to tell me what you wrote for question E? Let's see what you said.
Ma'am, my final answer, I got cos 90 degrees, and then the simplest I got 0.
Okay, all right, that's fine. So just explain to me what you did in your second line of working. So you would have obviously kept cos 65 as cos 65, right? How did you write
Yes,
cos?
ma'am.
Okay, how did you write cos 295?
No, ma'am, I didn't write 95.
No, well, you would have had to reduce this one, wouldn't you? So you would have had to show a reduction formula here, or shown what you got when you reduced. So how did you reduce cos 295? I think we might have lost Ria. Okay, Kagiso, that's exactly
ma'am.
right. Okay, so we would have ended up with cos 65 over here as well. Okay, now onto the second term, sine 115. How would we have written that, guys? Sine 115. Anybody want to tell me? Let's see who's got hands up. Okay, Boitumelo, go for it. How would you write sine 115? Boitumelo? Okay, let's have a look what you guys are saying in the chat. Okay, so Jade says we would end up with, okay, I see where you're going with this, Jade. Avio says sine 65. Boitumelo, okay, sine 65. Let's go back and go and have a look. Yes, so that would be second quadrant, so that would be sine 65. I quite agree. How would we write cos 205 matrix? Okay, Z2 not allowed to use 270 minus. Okay, it does exist, but you're not allowed to use it. Okay, it's got to be 180 plus, 180 minus, 360 minus, or a co-ratio. Okay, so because this is the third quadrant, we would write it as negative cos 25. I see somebody is telling me. So negative cos 25. So third quadrant cos theta is negative, and 205 would be 180 plus 25. Good. Okay, so now, yes, there we go. Okay, so now that we've got this far, all right, we've got cos 65, cos 65. A negative times a negative is a positive. So I'd write there as plus sine 65 cos 25. Okay, now what are your ideas? What can we do here? All right, so a whole bunch of people put their hands up. Kamogelo, go for it. Yours was up first. What would you do here, Kamogelo?
Hi, ma'am.
Hi, Kamogelo.
So, since that's cos 65 multiplied by cos 65, we already know from our, like, those equations we have. What do we call them equations?
Your
Yes,
compound angle formulae,
my
these ones
compound.
over here.
Yes, so
Yeah.
we have cos A, it's similar to cos A plus sine, sorry, cos A multiplied by cos B. It's similar to that. So we're
It
gonna
is.
reduce it.
Okay, it's already reduced. It's already reduced. When we say something needs to be reduced, we mean that we need to write an obtuse angle or a reflex angle as an acute angle. That's what reduction is. Okay, so they are already reduced because they are all acute angles. The problem here is that if we want to use a cosine compound angle, we have to have cos, cos, sine, sine. Okay, we've got cos, cos, sine, cos. All right, so that means that something's got to change. All right, what can we change?
Okay,
There we
I
go.
think we. Oh, okay, sorry. Thank you. Bye.
No, that's fine. Well done. Okay, so Bayanda says, ma'am, isn't the first cos 65 supposed to be cos 90 minus 25? Okay, and then Chloe says, cos 25 is sine 65. You're quite right, it is. Okay, what do we want to change though? What are we going to change here? Okay, Boitumelo, do you want to say something?
You can unmute Buitu. Okay, maybe Buitumelo disappeared somehow. You guys did really well, by the way.
You have done really well. Okay, so we want to change cos 25. What do you want to change cos 25 to? To sine 65. Okay, so are you guys suggesting that we keep cos 65 as it is and cos 65 as it is? And here we go sine 65, and then here we go sine 65 as well. Is that what you're suggesting? Yes. Okay. All right, well, it's not wrong. Is it going to lead us to a solution? Now we've got cos, cos, sine, sine. Okay, so cos does not keep its sign. So cos, cos, sine, sine, we've got a plus in between over here. So it's going to look like this one over there. All right, so now it looks like the right-hand side of one of our compound angles. So now we need to do a reversal of the expansion. Okay, so this means we do 65 minus 65, okay, which would give us the cos of 0 degrees. And the cos of 0 is what? What's our final answer? I think someone's already said it before. There we go. All right. It would be 1. Lovely. Good. Well done. Very nice. Very, very nice. Zwanaka, do you want to ask a question?
Ma'am, I was going to also say it's this one.
Oh, okay. All right. Good. Yes. Well done. That's brilliant. Kamogelo, do you want to ask a question? Well done. Kamogelo? Any
Ma'am,
question? Yes.
so on the part where you change the sine 25, I changed the sine 65. So I said
Okay.
sine 90 degrees minus 25 degrees, then I said cos 25, and then it means I'm gonna have cos 25 and multiplied by cos 25. And then going down, I'm gonna have sine 25 plus cos 25, and then it's gonna give me cos 25 minus 25, and then it's gonna be cos 0, then it's gonna give me 1.
Okay, so that would just be an alternative way of doing it. I would like to actually see what it is that you have written on your page, but just listening to what it is that you've said, I don't see that that would be a problem. Okay, often there's more than one way to do these questions. Sometimes there can be 3 or 4 different ways even to be able to do one of these questions, but that doesn't sound wrong to me at all. Okay.
All right, thank you, ma'am.
All right, no problem. Okay, have we taken everybody's questions? Zetu, did you want to ask a question or was just your hand up from earlier?
Ma'am, I want to ask another question.
Go for
Could
it.
you have done instead of doing the cos graph thingy, could you have done a sine one?
You mean could you, and so instead of, so in other words, instead of changing this cos over here to sine 65, are you suggesting that we then go and change, for example, one of these, either one of these, so this one here or that one there, to sine 25? Sorry, yeah,
Yes, ma'am.
yes, absolutely, absolutely. What you would need to do then, though, is that you would have to switch the terms around. So yes, absolutely. So in other words, let's just have a look at that very quickly for you. So if you've got cos 65 plus sine 65, and then here you've got cos 25. All right, let's change one of these. So let's take that one over there, and we could write that as sine 25 cos 65 plus sine 65 cos 25. Okay, so what I'm going to do is I'm going to switch the order of these two terms. I'm going to write this term first. So I'd write that as sine 65 cos 25 plus over here, I've got cos 65 sine 25. So I've written that term over there. And then I've also, the order in which I multiply doesn't matter. Now I'm working with a sine compound angle. All right. And sine keeps its sign. So I'd end up with 65 plus 25. Mind you, if I'm adding, it's not going to make any difference whether it's 25 plus 65 or 65 plus 25. But anyway, there we go. And then that gives us the sine of 90. And we know that the sine of 90 is 1. So you could do it that way too. Yeah, absolutely. Not a problem.
And ma'am, so what if you wrote your answer for sine 90 as square root 4 over 2, but you didn't press the SD button to get you 1?
Okay, but now the problem is you can't write it as the square root of 4 over 2 because it's, oh no, sorry. I'm talking absolute nonsense. It would be the square root of 4 over 2. Now that wouldn't, you know what? I would say that they might take a mark away from you because it's not fully simplified. Because we know that the square root of 4 is 2, and 2 over 2 would give us 1. So yeah, I would write that in a simplified way. But I can understand why you're doing that. You're using special angles.
Okay, thank you, ma'am.
Okay, no problem.
Yeah,
Okay, guys.
fully. That's what they said.
Well done. It's so nice for us to be able to talk about the different ways in which we can answer these questions, especially when it comes to trig, because as we were saying, there are lots of different options. Okay, well, that means that we're now out of time, everybody. We need to say goodbye. Please do try the quiz. And thank you so much for joining us. Have a lovely long weekend, everyone. And we will see you on Tuesday.
Yeah, come back with nice stories to tell us also.
Yes, absolutely. Okay, bye, everybody.
Thank you. Bye-bye.
Thank you. Bye.
Sorry, Teacher Lee, I'm just going to leave now because
No, that's
is it
fine. No
fine?
problem.
Okay.
Absolutely.
Thank you.
Pleasure, everybody. I hope you enjoyed our lesson. Bye, bye, bye. Miss Lali, to where? You said you wanted me to go back up to the top. Which top? Oh, pleasure, Ntlafatso. Okay, bye everyone.
Oh, teacher, before you leave,
Mm,
I've
yes.
noticed that on E,
Mm-hmm.
like how you did it is way shorter than how I did it. Mine is way long.
Yeah. So you know what? If you keep practicing this, you'll find that it will become easier and easier for you to find quicker and shorter ways to do it. So just keep practicing, okay? And then eventually it will become easier, especially as you become more confident with your co-ratios as well. They're so important in matric. So like what we were doing in that last question where we were writing sine 65 as cos 25, etc., etc. Okay, that will become easier for you.
All right, ma'am. Thank
All
you.
right. Pleasure, Kamogelo.
Bye.
Hi, ma'am.
Yes. How do I pronounce your name?
Ma'am, you can just call me. You can just call me Mac. It's fine.
Okay, Mac, that's a little bit sorry, but forgive my terrible pronunciation. Go for it, Mac.
It's
What's
okay,
your
ma'am.
question? Thank you.
Okay. So by the last question that we did, by sin 65 plus 25, is it possible that you just write your answer straight away as 1 instead of like I'm writing the 90 first and then the 1?
What you know what? You should actually show all those steps. You should
Okay.
show all those steps. Like here, I didn't need to rewrite that twice. That was a little bit of a long step. But you should write this line over here where I'm drawing an arrow. You should write sine 90,
Yeah.
and then you should write 1. Absolutely.
Okay. Thank you, ma'am.
Okay, no problem.